All right, so we're in the practice stage of whatever section we're on, 5.2 I believe. We're in the practice stage and just doing some examples. So the questions are normally worded something like this. Find the volume of the solid that's contained between a couple lines. They'll give you boundaries or not, contained between these two functions, and revolved around, they got to tell you which axis we're going about. So basically this says, find the area that's between there and revolve it around the x-axis. That's going to make some sort of a solid that's going to have some sort of a volume. You with me on that? Now, just as a refresher, if we are revolving around the x-axis, note that your equations should be solved for y. They should be x in terms of x. So y equals and then a whole bunch of x's. That's what solved for y or in terms of x mean. So around the x must be dealing with x's. You got it? Around the y must be dealing with y's. So my question is, if we're going around the x, are these okay?
Yes.
Absolutely okay. Yes, we're going around the x. They are in terms of x. In terms of x means solve for y. And these are solved for y. So this is in terms of x and in terms of x, which says this, all the terms have x's in terms of x. The terms are based on x. You get it? So those are perfect for us. Now the problem is, do I give you any bounds right here? Do you know which one's on the top right now? Do you know which one's on the bottom right now? So those are things we're probably going to need to figure out in order for us to set up our integral. Remember that the volume is, I think I gave this to you last time, a to b pi f of x squared minus g of x squared dx. Did I not give that to you? But this implied that f of x was the top function. G of x was the bottom function, so we need to find those things out. We also need to know, well, it says the volume in which the area contained by, we need to know where to start and stop. So where the area starts and stops, according to the y or the x in this case?
The x.
Because we're dealing with x's, that's right, according to the x-axis. Nod your head if you're okay with the idea of this so far. So how do we find out, this goes back to our area problem, very similar idea. How do we find out where these things are contained, where the area is contained? Say it again? That's exactly what we would do to find the area between two curves, right? Well, hey, all we're doing now is finding the area between, look at that, the area between two curves, and then taking the circles when we rotate them around. That's all we're doing here. So this really says take the area between the two curves and revolve it around. That's what we're doing. So what we need to do first is exactly what you said. Let's set these things equal to each other, figure out which one's on the top. So what we want to find is the intercepts. Where they intersect, where they intersect. By they, I mean the functions. And also which one is on the top. Okay, so let's find out where they do intersect. If we set them equal to each other, this is kind of nice because it's already solved for y. Basically, we have y equals x squared and y equals x cubed. Setting them equal to each other gives us x cubed equals x squared. Still okay with that so far? Solving that, well, we get what? What would you do to solve that? Probably because you're going to be using some sort of factor. X cubed minus x squared equals 0. Now what? If x squared times x minus 1 equals 0, can you solve for my x's, please?
0, 1.
Perfect. Not so bad. In fact, it's very similar to what you did for finding the area because that's exactly the same idea that we're doing, only we're revolving around some sort of an axis. Now do you know where your integral is going to start and stop? That's pretty great. So we can already start filling this thing out. The volume is going to be from 0 to 1. Not a problem. That's where these functions intersect. Therefore, the area must be contained between those two things. Okay, they got to be between there somewhere. Now, what we need to do is find out which of these functions is on the top for that interval and which of these functions is on the bottom for that interval. How do you do that?
You can put something in between the points.
Remember doing this? Remember doing that? I gave you the graphic organizer. I said, plug a number in there. Plug it into x cubed and x squared in this case. Figure out which one's on the top and which one's on the bottom. What number are you going to plug in between 0 and 1? 1/2 would be great, 0.5, whatever. With something between there, it doesn't really matter as long as it's not 0 or 1. So plug in 1/2 to both of them. This gives you 1/8. This gives you 1/4. Which one's on top? X squared is a bigger number than, I'm sorry, 1/4 is a bigger number than 1/8. Therefore, x squared is on the top. X cubed is on the bottom. Is this coming back to you at all? Do you feel okay with our setup thus far? Well, we already know where we're starting, where we're stopping. Let's go ahead and figure out the rest of this thing, the rest of our integral. We already know what our f of x is going to be in this case, the top function, and the bottom function is going to be in this case. So let's continue. What's the next thing I should write here, ladies and gentlemen? Yeah, they're all going to have a pi. That's from the circular nature of revolving around an axis. Then we'll have a big parentheses. What goes next? Just x squared? Now you don't have to use brackets, you can use parentheses as well. Just make sure you have the right idea. We take the top function, we square, that's what it says. Take the top function, square it. We have that. Take the bottom function, square it. We have that. Top, bottom. Now we're set, we're ready to go. Raise your hand, feel okay with doing all this so far? Not bad. Do you see how similar it is to finding the area? Very, very similar. Can you do the integral? Sure. What are you going to do first? Probably pull the pi out. Square this, you're going to get x to the 4th. Square this, you're going to get x to the... Perfect. Perfect. Now when we do the integral, remember to actually do the integral. What this means, notice how I'm writing these things. I've seen some notation problems in some of your work. Notice that when I do the integral, firstly, I actually do it. I do x to the 4th, and I don't plug in numbers to x to the 4th. I first need to go x to the 5th over 5, of course. Also notice that when I do the integral, I've stopped writing the integration. I have the bracket, sure, but I've stopped writing the integral. That's not appropriate. If you take an integral, you stop writing the integral. Minus x to the 7th over 7. And this is how you show you're going to evaluate. Off to the right-hand side between 0 and 1. Also, there's a few people who have forgotten that sometimes 0 is a number you have to plug in and is not going to give you 0. In this case, if you plug in 0, yes, you're getting 0, no problem. But if I had like an x minus 1, and you plug in 0, that's not going to give you 0, so be very careful on that. So let's go ahead and do the rest of this. If we do pi, plug in 1 here and 1 there, you're going to get 1/5 minus 1/7. And just to make sure I'm not forgetting anything, I'm going to check to plug in 0. 0 over 5, I know that's 0. 0 over 7, I know that's 0. So I'm going to write the 0 just to show that I've done it, that I haven't forgotten about it. You don't want to forget about that thing. So basically we have 1/5 minus 1/7. Do 1/5 minus 1/7 for me, please. 2/35. Or in other words, I think 12/35.
Oh, wait, no. Yeah, because I don't know.
Should be 7/35 minus 5/35 should give you 2/35. It's all good. You guys able to get 2/35? 2 pi over 35. Don't forget the pi. I mean, that's important, right? I don't want to leave that hanging. That's going to really change the answer. Any questions on that one before we go to the next one? Remember, this is practice. You know how to do all this stuff at this point. We're just kind of practicing to get a real good feel for it. Are you ready for another one, or do you have any questions? Okay, let's switch something up a bit. Talk about a different type of problem. Maybe not around the x-axis. Maybe we go around the y-axis. So the same idea, I'm not going to write the whole thing out. Area contained by y equals x squared, x equals y squared. That should be fun. Around y-axis. Now, could you please tell me something? Would you please tell me that if I'm revolving around the y-axis, what must my functions be in terms of? So solved for x. Solved for x means in terms of y. Means your terms are y's. That would be solved for x. So in our case, which one is okay for revolving around the y-axis? Is this one okay for revolving around the y? Is this one? That's perfect. This is what we want for revolving around the y. For the method of discs and washers, that's what we want. This one, not so much. If we're revolving around the y, change it. How are you going to change it?
Square root. X equals the square root y.
Very good. Now, I think we're neglecting something here. Really, when you take a square root, you should have a plus and minus, right? However, this function is only going to intersect the positive version of that. If you think about that, you have, well, I could draw it, I suppose. Y equals x squared. You have x equals y squared. That's the only intersection that's happening. So we're going to neglect the negative version of that, x equals y squared, just because it wouldn't intersect anyway. Do you follow me on that? And you could show it by actually setting it equal, but you're not going to get a real solution out of it. It's not going to happen. Or you get some false solution. So are you okay solving for x in this case? Take a square root, plus and minus, yes, but the positive or the negative really isn't going to affect us in any way, shape, or form, so we're going to ignore it for us. Now, what do we need to know after that? To set, remember, our whole goal is to try to set this thing up.
What's on top? Oh, we need our balance.
We need the balance. Remember in terms of y, so everything's got to be in terms of y, nice and neat. Someone said bounds. How do you find bounds? Now, check it out. Do you see why you need this in terms of y? If I set the functions in terms of y equal to each other, I will be solving for y's, right? And this is around the y-axis. It would be useless to solve for x's if I'm going around the y-axis. That wouldn't make any sense. That's why I have in terms of y. All right, well, set them equal to each other. I know x equals square root of y. I know x equals y squared. Therefore, if x equals the square root of y and x equals y squared, that means square root of y equals y squared. So far, so good? Solve for y. How would you do that? Hmm? Not yet.
Well, you know, looking at it.
Without just by looking at it.
Change the square root.
How?
Flip both sides.
Square both sides might be the best way to go. How do you get rid of a square root? Square root.